And welcome to PA Academy. So in this video we are going to be looking at the concept of analytic function. So we are going to be looking at how do you determine if a function is analytic or not. Alright, so that's what we are going to be covering in the course of this video. So before we get started, if you are new to the channel PA Academy or you are yet to subscribe, kindly go ahead right now, click on that subscribe button, okay, and the bell icon beside the subscribe button. So go ahead and do that right now so I can get updated anytime I upload a new video. So we are waiting for you. Just take out 1 or 2 seconds to click on that subscribe button. Alright, so thank you very much if you have just done that. So now let's look at what we mean by analytic function. So the condition is a function is said to be analytic if it obeys the Cauchy Reimann equation. Alright, and what is that equation? So if du over dx is equals to dv over dy, and if you have your du over the y is equals to minus dv over dx. Okay, so once you are able to differentiate your function and you are able to get this relation like this, like you must have the two at the same time, then you can say the function is said to be analytic. Now let's look at one example. So let's look at our example 1. So here we are given that verify if f of z, which is equals to z squared, is analytic. Okay, so now let's do this together. Now if you have been following our previous videos where from complex numbers and complex variable, you understand what this is, that if we have our f of z, okay, so for this now we are told that our f of z is equals to z squared, and then which is x plus jy, that's the real and imaginary parts all square. Okay, so that's, if you are dealing with this, your z simply is your x, which is the real, plus the imaginary. You can also be in form of a plus jb. Okay, so that's just by the way. So if you should expand what we have here, so this will give us x plus jy and then x plus jy. So we've done this in the previous video. If you should expand this, we are going to be having x squared plus 2, let me ask, jxy plus j squared y squared. All right, so if you have to simplify this further, we are going to be having our f of z, okay, to be equals to x squared. Now this j squared, like I've said in the other video, j squared when you are dealing with complex number is equals to -1. Okay, so this -1 multiplied by y squared, that will give us minus y squared. So we can bring it here to be minus y squared, then plus 2jxy. All right, so with this now we can separate it into our real and imaginary parts. So in doing that, our real part, which is u, is going to be x squared minus y squared. All right, and then y, our imaginary part, which is v, will be this is our imaginary part right here. So like I said, the imaginary part is the one that is having this j right here. It could be j, it could be I in some cases. Okay, it's going to be 2xy, so we don't need to include the j. So now remember what I said about it must obey the Cauchy Reimann equation. So now we have to apply this. Okay, so let's start with du dx. We are going to look for all of these and see if they equate each other. All right, so let's start with the real part. So that's du over dx. Okay, so let's differentiate this with respect to x. So in differentiating that, we are going to have it to be 2x. Okay, then also du over dy. Okay, so that means we are differentiating this, okay, with respect to y. All right, so if we should do that, we are going to be having, because of this 2 square here, that's going to be minus 2y. All right, so let's do the same thing for the imaginary part. So that will be the v over dx. All right, so if you should differentiate this with respect to x, we are going to be having 2y. So that's going to be 2y. And if you should also do the v over dy, that is going to be 2x. Okay, so now let's go ahead and compare if we are going to get that. Okay, and don't forget the equation again says if a function is said to be analytic if our du over dx is equals to the v over dy, and if our du over dy is also equals to minus dv over dx. So now let's look at it together. Our du, this part here, over dx, this is it right here, is 2x So what about our dv over the y? Okay, so our dv over the y, this is it right here. You can see it's also equals to 2x. Okay, good. The first equation, it obeys it. Now let's look at the second one. So now we have the du over the y, which is right here. So our du over the y is minus 2y. Then our dv over the x, which is this right here, is 2y. Okay, and remember there's a negative here also, so that's going to minus 2y. All right, so with this now you can see that it's both satisfied. You can see we're having 2x equals to 2x minus 2y is equals to minus 2y. So with that now you can just conclude that hence f of z equals to z squared is analytic. Okay, so that is it on analytic function. So this is the first example. We are still going to be looking at two other examples. Okay, so I hope this gives you the basic understanding when we are dealing with analytic function. All right, so if you have any question or any doubt, just let me know in the comment section. And if you still don't understand the concept, just take your time to watch the video again, or you watch it again and the other examples that's going to be coming after this. All right, so thank you very much for watching. My name is Prosper, and I'll see you all in example 2 of this video.